Section 8.2, the control volume and system representation. The definition of system is a collection of the matter of the fixed in identity, the same atom or the fluid particle, move or flow, interact with the surrounding. For the control volume is a confined volume in space with fluid may flow through. Okay, so we are interested in determine the force put on the fan and airplane or automobile by air flowing than the air or a system and its flow along using the control volume approach. Okay. An example of the control volume is show this A is a control volume surface is a fixed control volume, and for B is the you can see that is a system at time t1 in the red color and system at time t2, okay, in the gray from orange to red color. So if we want to fix, so we can fix like this is a dash line is a fixed control volume. Okay, and another example is the deform. We call the C is the deform control volume. Okay, and this boundary can be deformed from the balloon. Okay, and the control volume is a Euler description. The observation point is a fix. Okay, but system or Lagrangian description to follow the fluid and observe its behavior as it moves, and that is the different description of between the control volume and system. And the next topic is the Reynolds transport theorem. Okay, we represent the fluid property is B, capital B is equal to mass times the small b. So b is a fluid parameter or property. For example, velocity, acceleration, mass, temperature, momentum, and small b is a parameter per unit mass. Okay, so if the capital small b is mass, so if the capital B is mass, so small b is 1. Okay. M is the mass of fluid. For example, if the capital B, the fluid parameter is a kinematic energy, so small b is v squared over 2g, so it's a kinetic energy per unit mass. Okay. And therefore b and capital B and small b may be scalar on the vector. For example, for the momentum, the small b is equal to b, momentum per unit mass, or it is a velocity. Infinitesimal fluid property with the volume del V. Okay, and so we can find the del mass is equal to density times del V, and summation of all particles to form a system, B system, is the summation of the Bi times rho and volume. So this comes from dB. It comes from the small b times the dm, and for the mass is equal to density times volume, okay, times the small b. So we got this, the rho b del v, okay, as we seen from this integration of rho b dv d volume. Okay. Time rate of change of the property of the fluid system. So we can write that for the fluid property, the time rate is differentiate of B system respect to time is equal to differentiate of integration of rho B dV. But for the control volume approach, capital B is a B CV. So it's a differentiate of the integration of CV rho B dV respect to dt. Okay.